I'll try that again. We use scientific notation to describe really, really, really big numbers or really, really, really small numbers. Now, unfortunately, things in the electricity world are really, 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 really small. Okay? The charge on a single electron. Anyone know from chemistry class? What's the electronic charge, the electric charge on a single teeny tiny electron? Nobody? Does anyone remember that they were told it once? Okay. So it's all new to you. That's fine. I'm going to tell you what it is real soon. So but before we do that, now in the old days, they used to cover this in math class, but they don't do that anymore, so now I have to spend a day doing it. I used to be able to do it in about 10, 15 minutes, as kids had seen it before, but for the most part, has anyone seen scientific notation before? Just a few. Okay. So we'll review, and I'm going to show you how to use your calculator properly as well, because if you don't do that, you're going to be messing up on the test. So scientific notation is a way to describe really big numbers and really small numbers, as I said. So any quantity, any number can be expressed using a power of 10. And as you move the decimal point, you multiply by 10 as many times as necessary to make the numbers equal. So here's a couple examples, which I already know are a little bit confusing. So if I've got the number 325, 325 is the same, Trent, as 32.5. I gave you guys plenty of time. 325 is the same as 32.5 times 10. Would you agree? Okay? And we can write this 32.5 times 10 as 32.5 times 10 to the power of 1. Because how many 10s do we have? I've only got one of them. Right? Every time we move the decimal point, we are multiplying by 10. Okay. I can also write 325 as 3.25 times 10 times 10. 2 tens. Okay? So 3.25 times 10 to the 2. I can also write 325 as 0.325 times 10 times 10 times 10. That's 3 tens, or 1, 2, 3 decimal places, or 0.325 times 10 to the power of 3. So in other words, again, every time you move the decimal point, you are multiplying by one more 10. And you don't have to keep writing out how many tens, you just keep a running total right here. Okay? It can go the other way as well. 0.325 is equal to 3.25 times 10 to the minus 1. Okay, so you're going to see positive exponents, which are when the number is really, really big, and you're going to see negative exponents when the number is really, really small. Okay, now a number in scientific notation has two parts. The number in front of the times 10 part is called the coefficient. Okay, that's the part out front. The power to which 10 is raised is called the exponent, and there's a little diagram right there. Okay, I don't think you guys have any filling in the blanks to do at all, do you? I just printed it, yeah. It's the first time I've actually done this lesson. You guys are like guinea pigs. The coefficient must have one and only one digit in front of the decimal point. The exponent will always be a whole number in most high school science classes. So a couple of rules. This number will always be a whole number. It won't be like a decimal. Okay? And the coefficient can only have one and only one digit in front of the decimal point. And it's always non-zero. Okay? So you have to have one in front of the decimal. It can't be 0. Usually we put 2 here. That's just kind of a convention. So one number here in front of the decimal, 2 after the decimal, and the exponent has to be a whole number. Those are sort of the ground rules. Okay? And here they are here. 3 rules. To express a number in scientific notation, you move the decimal point to the position such there is one digit, not 0, to the left of the decimal point. If the decimal point is moved to the left, the exponent is positive. And that is when the number is big. Big, big numbers, like the mass of the earth. Okay? My IQ, big, big numbers. A couple of smiles, that's about it. I just do that to see if anyone's listening. If the decimal point is moved to the right, the exponent is negative. Really, really small things. My bank account, number of hairs on my head, really small things. Just checking to see again if you're listening. Number is small. Okay? Here's a mnemonic which might help some of you. I don't know. I'm not a big fan of this one, but I think I stole this from someone. I think I started this lesson about a year ago. I think I stole some of this off the internet, and I need to sort of make it my own. A mnemonic that might help you remember how to keep the sign straight is registered nurses love patients, or RNLP, right negative, left positive. I don't think that's necessary. I just think big is positive, small is negative. Okay? Let's get right into it. Here's the example. Now, here's where you actually have to fill in the blank, I think, right? You actually have a blank there? Please say yes. Okay, good. Oh yeah. So I want you to express 0.0003821 to some random number in scientific notation. So the rule is you keep moving the decimal point. I'm going to make it a little bit bigger. You keep moving this decimal point until you get to where? Do I stop there? Why do I stop there? Because I've got one number to the left of the decimal, right? And now I'm going to write my coefficient. So I stop with my decimal point there, and I'm going to write 3 point, and generally you only put 2 after the decimal point, generally. 3.82 times 10. Now, is it going to be positive or is it going to be negative? RNLP. I moved it to the right. RN is negative. See how hard that is to use now like that? Is it a big number or a small number? It's a small number. It's like the hairs on my head. It's negative. That's way easy to remember. Negative what? How many times did I move it? 1, 2, 3, 4. 3.82 times 10 to the minus 4. Now you might say, that seems like a lot of work. I don't get why I need to do that. Does that seem like a valid question? Okay. I want you to punch this number into your calculator. And the first question you ask is, how many zeros is that, Mr. Bennett? And even if I wrote them out nice, you would still go, oh, and you'd start counting and your eyes would go cross-eyed, you'd have to start again, and it would totally suck. That's why you need to do it, because that's how small the numbers we're going to be dealing with are. I just chose this one because I didn't want to move the decimal point 31 times to the right. That's how small these numbers are that we're going to be talking about. Okay? So yeah, it's important. The decimal point was moved 4 spaces. But the decimal point moves to the right, the exponent is negative. Since it moved 4 spaces, the exponent is minus 4. Notice that the decimal point was moved until one and only one non-zero digit was in front of the decimal point. Does that all make sense? Am I speaking English? Megan? Yeah? Super clear, or I still should do some more examples? Probably do a couple more? Okay. Good thing I have a couple. Okay, here's a really big number. 56,873. Maybe that's the population of Brandon, about. Maybe Brandon's a bit bigger, I don't know. 56,873 in standard rotation. So, here's how you do it. Where is the decimal point right now? Behind the 3. It's not there. It's not shown. This time we're going to have to move it to the left. 1, 2, 3, 4. Right? So that's 5 point. Now you should only put 2 decimal places. 5.69, and that's going to be times 10 to the power of. Is it going to be positive or negative? It's a really big number, like my IQ. That's a positive thing. Going to have a positive number. How many places did I move it? 1, 2, 3, 4. Again, it's 4. 5.69 times 10 to the 4th. Now, I just thought of something that always causes grief with some of the international students, especially the European ones, and the Francophones. They like to use commas instead of decimals. Still do. Okay, it causes problems. So it's got to be a decimal. I'll adjust. I'm okay with it. Okay, but be aware. Now, in the good old days, when I had 56,000 hairs on my head, we used to write, as kids, we would put like a comma every 3 digits. Have you ever seen that before? Okay, that's sort of old school. The metric way to do it is to actually put a space. Okay, so there might be a space. That's the correct metric système international way to do it. Okay, yeah. So decimal points. I'm okay. Okay, is this next? Okay, so we did one where it's really big, positive, and we did one that's really small, that's negative. Okay, there's way more to it than that because you're going to have to actually do it on your calculator. Now, here's where I get into fights with kids because they think they know how to do it. Okay? I'm begging you, please do it my way. It's going to solve a lot of problems. Get your calculator out. I want you to find either the EXP or the EE button. Sometimes it's like a shift, a yellow one. Okay? And you're going to need a real calculator, not a phone. Okay? So you're going to look for the EXP or the EE button. Some sort of newer calculators might have a times 10 to the X button. I think those are the sharps. Hunter, got one there? Yeah, okay. Okay. I'm pretty familiar with most calculators. I've seen them all over all my years. Okay, so if you are to do, here's the number here, 0.0003821. I want to punch that in as scientific notation. So we're going to do it manually in our head, or we're going to do it sort of maybe not in our head, but on paper. I'm going to move the decimal point to 1, 2, 3, 4. Same as before, I guess. This is probably the same number, isn't it? 3.82 times 10 to the, it's a negative small number, really small, negative 3.82 times 10 to the minus 4. So how do you do that on your calculator? Here are the buttons to press. 3, do it with me, 3.821, I guess I did here, 3.821. 3.821, and then you press the EXP or the EE button. Do not, I repeat, do not go times 10. Don't do that. Your calculator is not designed that way. The EXP means times 10 to the power of. That's what this means. Okay, do not do times 10. And I've said that 3 times. And there's still 3 people in the room that are going to try to do that. Don't. 3.821 EXP. Now some of you are going to go 4 and then the plus minus. And some of you are going to have to go plus minus and then the 4. You just got to figure out which way your calculator is. Some of them are sort of what they call reverse Polish. That's the actual term. It's not a stereotype against Polish people. Okay? Has everyone got 3.821 times 10 to the minus 4 on the calculator? I'm going to come around and show me your calculator. Oh, but you're in regular notation, right?
Yeah.
Can you show it to me? Oh, because you did it, you pressed enter, did you?
Yeah.
Oh, gotcha. Yeah, if you press enter, you're going to get it in really, 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 really small, right? Or you're going to get it like, yes, good. Are we good? Good? Okay. You guys in the decimal version there? Some of you are going to find. Okay. Yeah, okay, you did the times 10. Or did you just, no, don't do that. No, you can get it right there. You can go next one. Okay. Yeah. EXP. Yep. Yep. I'm looking for that E. This one right here. Yep, that's right. Nope. Nope. That means 3.8 times 10 to the minus 1. Yep. Yep. No, you got that means 1. Well, in this case, oh, in this one. Okay? Okay, looks like we're in good shape. Okay. Now, what if you have to multiply that number times something? Okay? So if you're going to multiply by 3, because you're going to come across this in the electric field unit here. So let's type it in again. 3.821 EXP 4 negative. That gets you the number in scientific notation. And then you just go, well, times 3. Okay? Now you might get a number like, in this case here, you're going to get, let me get my calculator, 3.821 EXP negative 4 times 3. Now you might get it as this, 0.0011463. Is that what you got? Excellent. Now, you should probably write that in scientific notation, shouldn't you? Right? So what's the correct answer? It's going to be 1. You're going to do this, right? You're going to take that decimal point, and you're going to go 1, 2, 3. So that's going to be 1.1. 1.1 times 10 to the 1, 2, 3. That's going to be a minus 3. 1.1 times 10 to minus 3. That's right. Now, wouldn't it be nice if your calculator automatically switched it for you? Mallory's figured it out already. How do you feel, Mallory? What just happened? Some calculators will automatically do it. Most will do it once the number of zeros gets to like 4 or 5. If you want to force it, you need to find the button. Mine, this one here has a big F and an E on it. If you have F, arrow, arrow, E, press that button. It will go into scientific notation. Some of you will have in letters, SCI, usually above the number 5. In yellow, you have to go second function, SCI. Some of you will have an FSE button, fixed scientific engineering. You got to press it twice to get to S for scientific. Every calculator's got its own way. I'm usually pretty much familiar with them all. So I will come around and I'll show you. It's usually easier for me to do it individually. Okay? Because it's just too hard for me to show every calculator. You have what? Yeah. I'm going to come around a bit. We'll figure it out. Yeah, these ones are pretty easy. Oh yeah, this one you gotta go to 7. I'll come back. Yeah, I remember that. That was the hardest one there is. I know. Sometimes actually the simpler calculators are the easiest. With the FE is the simplest one. Okay? I will show you, don't worry. I'm going to spend the rest of the period, I'll be coming around lots, okay? Okay, I want you to try converting those to scientific notation. Try them right now. Try those, I'll give you the answer right away. Let me do these ones here. The decimal is there. We're going to go 1, 2, 3, 4, 5. This is going to be 5.46 times 10 to the 5, right? This one here is going to be even bigger. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 5.68 times 10 to the 11. Yeah? Good? I assume some of you probably went on to the next practice one. If not, I'll leave them there. These you have to convert to standard, so put them back into regular, and then do the math. Try those. I'll be back in 3 minutes. Okay, so converting to standard notation, this is times 10 to the 8. 3.16. So you're right. I haven't actually done any of these, have I? Like, I didn't show you how to do these. Maybe you figured it out. So that's going to be 316. Now, how do I know how many zeros to put? It'd be really nice if it was just 8 zeros, right? But it's not. It's 8 moves of the decimal point. So you actually have to go 1, 2, 3, 4, 5, 6, 7, 8. But really, if you stop and you think about it, right, it's 3.16. There's 2 moves. Then I have to go how many zeros? 6, right? So 1, 2, 3, 4, 5, 6. With no decimal. 3, 1, 6, and then 1, 2, 3, 4, 5, 6. I'm never going to get you to do this, by the way, except now. But you need to be able to see how it's done. Okay, 5.67 times 10 to the minus 5. This time we're going to move to the left because it's a really small number. So it's going to be 5, 6, 7. I'm going to move it 1 decimal place, and then I got to go 4 more, right? So 1, 2, 3, 4 zeros, decimal point. Don't worry if that doesn't make too much sense. You'll never have to do that with me. Okay, now I want you to do the math. That's a divide, that's a multiply. Try those. I'll give you another minute or so. Okay, so to do the math here, you're literally going to take your calculator, which I've now lost mine. Okay, this is good. Not so much. Oh, here we go. Okay. So take your calculator and you're going to go 8.67, so 8.67. Remember the times 10 to the 4 is EXP or EE, whichever you have. 4. And then all in one step, divide by 5. Your answer should be 17340. Put that in scientific mode. You should get 1.73 times 10 to the 4. Yes? Okay, this one here, let's try this one, and then I'll let you go on your own. 5.23 EXP -3 times 7. And I get 0.03661. Convert that to scientific notation, and you get 3.66 times 10 to the minus 2. Okay? All right, so I gave you an extra sheet. It looks like this. You don't need to do it all. Like, if it's making sense to you, stop. Right? You don't need to do it all. Okay? The front side is simply writing in scientific notation. The back side is writing in standard notation. And then what I did was I added in some math at the bottom because that's what you need to be able to do. Okay, I just hand wrote that in.